Hello everyone, this is another video in which I'm going to solve another problem. This is binary subarrays with sum. I have solved such problems in the previous videos as well with the subarray sum key, but this in this video I have taken this problem in order to explain about another concept, that is why the sliding window can't be used in such problems. So before getting directly into that, firstly I will explain all the approaches for solving this particular problem, and then we will go and check that why the sliding window can't be used in these kind of problems. I have also added the timestamps for every part, and you can check them by jumping directly into them. So let's get started with this problem. The problem statement says is that we are given with a binary array nums containing only the zeros and ones, as this is a binary array, and we are having an integer goal, that is the key value. Subarray is a contiguous part of the array, and our task is to return the total number of subarrays whose sum is exactly equal to the goal. So the problem is simple, and the problem is saying that we are given with a binary array, that is the array which contains only the zeros and ones, and we have to just return the total number of the subarrays whose sum is exactly equal to that goal. So in the same way, when we have solved the problem for the subarrays with the sum k, here that this is the same problem, just we have to count all those subarrays. So let's firstly understand what are the approaches we can use to solve this problem. First approach, or the simplest approach I can say, that is use brute force again, by trying out all the possible subarrays, and for every particular subarray we will check the sum of it, and just like if it is equal to the goal or not. And if that is equal to the goal which is given to us, then we will have a count of that particular subarray inside the count variable, and at the end we will return the count as the total number of subarrays which are there with the sum equal to that particular goal. So this is all about the brute force, and let's just quickly get into the implementation part and implement it. This is the function, and here firstly I will be taking the size of this nums array. So nums dot size inside n, and now I will just have a count variable in which I will be the count of the subarrays, and now I will just use loops for int I equal to I less than n, I plus plus, and inside this I will be using another loop j equal to I, starting from I. For every particular index we will have all the possibilities of subarrays. J less than n, so this j plus plus. Now in this what we have to do is we have to every time go at a newer index, like first we will go at I equal to 0 index, and then for having all the possibilities of subarrays we will be having this j pointer, where we will be starting from I, and then it moves ahead one by one in order to have all the subarrays. Whenever we start for a particular index for its subarrays, we will just take the sum as 0, slice the sum as 0, and as the j moves forward we will just take the sum of that nums of j inside the sum equal to sum plus nums of j, and the moment this sum this nums of j gets added inside the sum, we will then just check if this sum is equal to the k or not. And any point of time where the sum is equal to k, we get to know that okay, this is a particular subarray with the sum k. We will just increment that count which we have initialized as 0. This is how we will get all the subarrays with that particular sum. At the end we have to just return this count. So this is a simple implementation you can write as a part of brute. So let's just take the input here. The input is 10101, size is 5, and is 10101. Let me take a value. I have to have the subarrays with sum equal to 2. Now let me just run it, and it will be giving the number of subarrays. There are 4 subarrays with sum exactly equal to 2. Here we can see that this particular subarray 12101, then another subarray is this 101, another subarray is 1010, and another subarray is from 010. These 4 subarrays are there with the exact which are having the sum exactly equal to 2. And now let's see the time complexity here. So particular two loops are running here which are having the n square operations, that is for 0, that is working from 0 to n minus 1, like and that is n times, from I equal to 1, so that will be working from 1 to n minus 1, that will be n minus 1 time, and similarly for I equal to n minus work for only 1 time. Therefore all the total operations, or can just sum up them, so that will give us n into n plus 1 by 2 kind of. that is n square. So time complexity is n square here, and space complexity is constant, just using a simple variable in order to return it at the end, the count of the subarray. This is all about the brute force approach. And now, because this is slow and also less efficient, so we will have to move toward a better approach. So better approach, we already know that we can use the prefix sum and the hashing approach as already discussed in the. So I will be just giving a brief of it. So applying the prefix sum and the hashing approach, let's understand it how. So whenever we are having an input array, we just take the prefix sum at every particular index, and then we check for the prefix sum minus key that I have already explained. Let's just see here. If we are having a particular input array just like this, and at any particular index we are having a prefix sum, so what we used to do is we check the prefix sum minus k in the past. If the prefix sum minus k exists at a particular index in a past, then after that index till this current index is a subarray with the sum key. Okay, that I have already explained in one particular video, of which I will add inside the I button. So that we have to do every time we have a prefix at a particular index, we check for prefix sum minus k. So if right now if we are at a particular index j and that prefix sum minus k was available at I index, then from that I plus 1 till this current index j is a subarray with the sum key. And because we have to count here, so we will just see that how many number of times that prefix sum minus k was available in the past. The number of times that prefix sum minus k was available in the past, that number of subarrays which will be formed, which will be ending at this current index j. That's all about it. And let's just perform a simple dry run on this example. Here I will be using an ordered map so that I can store the prefix sums and along with their frequencies, that how many number of times that particular prefix sum came in the past, so that I can just take it as the count, that number of subarrays, that these are the number of subarrays which are available, will be ending at the right at the current index. So this is the unordered map here I have taken. I will be just naming this map as a frequency map, because I will be adding the prefix sums with their frequencies. And I will also have to maintain a prefix sum. Let me just take this side, and also I will be taking the prefix sum maintained here. Initially it is the count will also be maintained here. The count is also 0. So let's get started. Firstly, I is pointing at 0th index. I is pointing right now at 0th index, and here 1 is the element, and we will have to add this in the prefix sum. So 1, when 1 is added, the prefix sum becomes 1. And now we check for okay, so what value we have to check? We will take a small, let's say I have 2 here, which the subarrays with the sum 2 I want. This is the goal. And now I will check for 1 minus 2. Prefix sum minus key, that is 1 minus 2. So minus 1, I am checking for the minus 1 inside the prefix sum if it is available in the past. Minus 1 is not available. And one thing also which we have already discussed multiple times, that initially this particular prefix sum was 0. Okay, so this is a kind of virtual prefix sum which we will have to store inside the map along with a count of 1. So that later on, whenever any subarrays comes with which are starting from the 0th index, we can take them into consideration. Initially, this 2 along with its frequency count 1 will be present inside the map. Now, as this 1 is seen here by I, so 1 will be coming and added inside the prefix sum. And now we will check for 1 minus 2. Minus 1. Minus 1 is not available inside the map, so we cannot do. Just add this prefix sum 1 inside the map. And now this is for one time. Now I moves ahead. And I moves ahead, it sees a 0, and then 0 will be added inside the prefix sum. So the prefix sum will remain the same. No any change. Again, it will see for prefix sum minus goal, means 1 minus 2, that is minus 1 is not available inside the frequency map. So again, this particular 1 will be added. This prefix sum will be added along with its frequency, means 1 for another time. What we seen is the prefix sum 1 was available once till at the 0th index. Then because of the 0, the same prefix sum got repeated here. So again the 1 present at this 1 index as well till this 1 index. So because this is a frequency problem for counting the number of subarrays, we will have to add the prefix sum, the repeated prefix sum also inside the map, so that we can have a correct count the how many number of times that it came. Because once again this one came, so here it will be updated with. Now I moves ahead, and I moves ahead, it will now see a 1, and 1 will be added inside the prefix sum, and this becomes 2. prefix sum 2 is there, and now we will be checking for prefix sum minus goal. This is 2 minus 2 to 0. Is the 0 available inside the map or not? So yes, we have seen a 0 that was at one time. Okay, so this 0 comma 1, 0 is found inside the map and that was at one time. So therefore we can just say that the second value, the 0 was found one time, so therefore one subarray is there which is having the which is having the sum 2. This particular second parameter will be added inside the count, and the count will now become 1. And now we will have to add this prefix sum inside the map. So 2 prefix sum came at this second index for one time till now. 2 will be added along with its count. Now I moves ahead and it will again see a 0, and because of which the prefix sum will remain the same. Okay, so now we will again check inside the frequency map that is this 0 available or not. Yes, 0 is available and that was one time. So here in the array we can see that prefix sum was 0 at this place, means where we have not started taking the sum. And after that from 1010 till this third index 0 to 3, this is the subarray which is having the sum 2. The map is also saying that the prefix sum 0 is available one time till now. Therefore, one subarray will be formed, this 1010. Again, the second parameter value will be added and this will now become 2. Subarrays we have encountered so far with the sum 2. What are the subarrays? One is this 101 and another subarray is 1010. Now again, when this I moves ahead, it will now see a 1. And now this 1 is added inside the prefix sum and this prefix becomes 3. Now we will see in the map that is this prefix sum minus goal, means 3 minus 2 is available inside map or not. Yes, this 1 is available. 3 minus 2, 1 is available inside the map and that was encountered two times till now. Once it is available at the 0th index, and after that from at one index, so 1 0. This particular itself is giving the sum 1 and 1 0 is also giving the sum 1. So from here we can see the second parameter. The second parameter value is 2. Therefore the two subarrays will was this prefix sum minus goal 3 minus 2 1 was available two times in the past. Therefore, two subarrays will be formed which will be ending at this current index. What are the subarrays? One subarray is this 0101 because this one sum is there at 0th index. So therefore, from here to here, this 4th index, one subarray with with sum 2, and after that one was also available at this one index. So therefore, from this second to 4th index, this is also giving a subarray with the sum 2. So therefore, this particular 2 will be added inside the count. Now the count will become 4, and then this prefix sum will also be added inside the map, so it will be added along with its count, that is one time till now. And then I moves ahead and I moves ahead, therefore the process will stop. Now inside the count we can see count is having 4, means the 4 subarrays are there with the sum or the goal as 2. So at the end we can just return this count. It's all about the prefix sum and the hashing approach. And let's just get into the implementation part in order to just implement it for this particular logic. Okay, so we have seen the logic for the prefix sum and the hashing approach, and now let's just implement that thing. Here, let me just take the unordered map firstly. Unordered map, and it will be having the two parameters. One is for the prefix sum and another is for its frequency. And I will just name it as frequency. And also we have to insert the 0 along with its count of 1. So we will be just the frequency of 0 as 1. And after this I will just take the prefix sum. I will just take prefix sum variable to have the prefix sum. Sum will be initialized by 0 as of now, and also I will be taking count variable so that I can have the count of subarrays. And now I will be just running a loop for auto val, and inside this I will be just taking the values every time from the nums array, and then I will just add these values inside the prefix. So prefix sum plus equal to 12, and after this I will just check if this prefix sum is available inside the map or not. So inside the frequency map I will just check with the help of find function that if this prefix sum minus the goal it is available or not. That is with the help of this condition frequency dot end And if this condition is true, then the iterator will not be pointing at the end position, therefore it will be not equal to the end position. So the condition will be true, and we have to just take the count of it. What count? Whatever the second value is there, the second parameter is there, that will be giving the number of subarrays which are ending at that current index. For that, I will just take this count, and count equal to count plus that frequency of the key, frequency of the prefix sum minus frequency minus sorry prefix sum, this frequency of the prefix sum minus pool. That will be basically giving me the number of subarrays, or the count, that how many number of subarrays will be there. So this is going to give that number. Now I will not have to check for any values for the prefix sums if it is available or not. I just have to add that prefix sum inside the map every time with a count of 1. So I will take that particular prefix sum inside the frequency map. So frequency of this prefix sum plus plus, and at the end I just have to return that count, return the count. Okay, so this particular implementation we have written, and this will be giving us the number of subarrays which are having that particular goal 2, or the sum 2. So this is all about the prefix sum and the hashing approach. And now let's check the time complexity and the space complexity. So here one loop is used for every value, and because the unordered map is used, so therefore uh, the find operation, the insertion operation, these particular operations takes the constant time. So therefore the time complexity will go to big O of n. And also for the space complexity, if there are the distinct prefixes, the different prefixes, then they will be getting inside the unordered map. And in the worst case scenario, it can lead to O of n space complexity. So this is all about the prefix sum and the hashing implementation and its analysis of the time complex space complex. So let me just run this. So we have seen the prefix sum and the hashing approach as well, along with its implementation and the time and space complexity analysis. Now let's get into the important concept where we understand why we can't use the sliding window approach in order to solve this particular problem. Let's get into the example. So because we already know that the sliding window works only in the cases where the non-negative values are there. So here we know that the non-negative values are there, the ones and zeros are there, no any negative values there. And we know that it works only for the positives. We are having positive elements, but still the sliding window can't work in this case. So I will not just directly get into the reason, or I will not just directly tell the reason that why it doesn't work. We will just perform a dry run on this with the help of sliding window. Later on with this particular flow, we will come to know that where this approach exactly fails. So we know that how the sliding window approach works. So what happens is, we are having in this input array, and we just take the 2 pointers, both pointers at the 0 position, where one pointer is the left pointer and another is the right pointer. These both pointers are used in order to form a window inside this input array we are given, or in the example. So with the help of that, we can just form a window and then check for the sum, the status of the sums, like if the sum is equal to the goal, or if the sum is greater than the goal, or if the sum is less than the goal. So if that particular sum is greater than the goal, then in that case we just shrink the window from the left, and we just perform this particular thing repeatedly until we get a sum equal to k, like equal to goal or less than the goal. And if in case the sum is less than the goal, then we just increment the sum, or we can say we can expand the window from the right pointer with the help of right pointer. Okay, so this is the whole approach, or we can say logic behind this using the sliding window technique. Now let's just perform the dry run on this, and let's see where this sliding window approach fails in this particular problem. So firstly, I am taking the I pointer here and one j pointer here at the 0th index. So these both are the pointers where this I is the left pointer and this j is the right pointer. With the help of this j pointer, we will just add the values inside the sum. So let me just take this sum as 0 for now, and our goal is equal to 2. That means the sum is equal to 2, which we want from the subarray. Now let's start from this. So firstly, this right pointer, j pointer, is pointing at the 0th index. Now 1 will be added inside the sum, and it will now become 1. Now we will check with the goal. We will compare with the goal. Is this sum less than the goal, or greater than the goal or equal to the goal. So because we can see this is less than the goal, so therefore we must add more inside this. Now j moves ahead, and when j moves ahead, because this is a 0, so it will again form a same sum, that the sum will not be changing. Therefore the sum is again 1. We will now again check with the goal, so it is still less than the goal, so therefore we will have to add more. Now j points, now j moves ahead, so it will now again see a 1, and it will be added inside the sum, which will now become. Now we will check the status of the sum. Now sum is equal to the goal. So we can now see that okay, this is a particular subarray which we got, which is present inside this particular window. So this window is now telling us that this is a subarray with the sum 2, or the goal 2. And in this case we can, okay, we also have to maintain a count for this. Count will be 0 initially, and later on when we get this particular subarray, as the sum is equal to the goal, so we can come to know that okay, there is a subarray inside the input array. So I can just increment this count. Now now again, okay, so now still sum is equal to the goal, so we have not come in the case where sum is greater than the goal. Okay, so now again we will move this j pointer ahead, and we can see that there is a 0, so again no any change will be happening in this sum. It will still remain 2, and because it is still 2, which is equal to the goal, therefore one more subarray we got, this 1010. The count will again be incremented by 1, and it will now become 2. So 2 subarrays we have seen so far. Now again, it is still 2, it is not greater than 2, so that I have to shrink this window. Now let's maybe one more 0 is there after moving this j pointer ahead. So now let's move this j ahead, but it now sees a 1, and when this 1 is added inside the sum, it will now become 3, and it will now check the status with, like, compare this sum and goal. Sum is now greater than the goal, therefore we must decrease something, or I can say we must shrink this window, so that this sum can become either equal to the goal or less than the goal. So therefore with the help of this left pointer, we will just shrink this window. So now 1 will be decremented from the sum, so it will now become 2, and now the sum is again become 2, so we can see here that it is equal to the goal, so therefore one more subarray is formed, therefore the count will be incremented to 3. So now the count is 3, it means we are having 3 subarrays with the sum or the goal equal to 2. And after this, when just when immediately when this gets decreased, I will move ahead. Means it might be the case that sum is still greater than the goal, so it has to decrement some more thing from the left, so that the and in that case the window will get shrink. Now we know that this sum is equal to the goal, so we need not to shrink this anymore. So therefore what will happen, we will have to just expand this window in order to get more sum. So now when this j moves ahead, so now we can see that okay, the j moves ahead, and it got out of the indexes, therefore this particular process is stopped. Okay, because the window is not valid no more, window is not valid now. So we can see here the process is stopped, but the count is 3 only, you can see here. Okay, and now we can see here that when this j was present at this particular index, we have already seen this particular subarray, this 0101, and it was giving the sum or the goal equal to 2. We have counted it, and the count became 3. But what about this particular subarray? This 1010 is also a valid subarray, which is giving the sum 2. But because this I pointer is not moved ahead, therefore this subarray has not been counted. Okay, so now we have seen this. Now let's just build the observation from here, that what has happened because of which this particular subarray, this valid subarray, got missed. So this valid subarray got missed because this I pointer didn't move ahead. And what's the reason behind it? See, the sliding window works, or the sliding window is built on a particular assumption that whenever we are having a fixed pointer j, for that particular fixed pointer j, there will only be a unique position where the I pointer will be pointing, or we can say there will only be at most a valid I pointer position. It will not be pointing at the multiple positions. But what the problem we are solving? The problem we are solving for, in order to count the subarrays with a particular sum. And in that case, we already know that if we are at a current index, then for that current index, there can be multiple valid subarrays which will be ending at that particular index. But this is becoming contradictory. That's if we are using the sliding window approach, and if we are solving this particular problem for counting, these both things are contradictory, because the counting problem says that at whatever index you are standing right now, the multiple subarrays can be there which will end at this particular index. But what the sliding window is saying, for every fixed j pointer, there will be only at most the one valid window which can be formed with the help of this I and j. So therefore, because this I is pointing at this one index itself, so it is only giving this subarray with the sum 2. But we already know that this from second to fourth index is also one subarray, but because I is not moving at that particular index, so therefore that subarray is getting missed. And that's what the reason is coming here, that we know that the sliding window works for both the positive, like for all the positives and the zeros. If no any negative elements are there, the sliding window works in that case. But here the positives are there, no any negative elements are there, we can see here. So now what is the exact problem? The exact problem is not the values which are given inside the input array, but because they are maintaining the monotonicity, which is one rule inside the sliding window, is whenever we go across in this particular input array, and whatever the values are there, when they are added inside the sum, it will either increase that particular sum or remains the same. The monotonicity behavior is not broken. So we can say the problem is not about the values which are given inside the input array, but the problem is the requirement. The requirement can be varied, like whenever we have to find for the longest subarray or shortest subarray, or in case if we have to find any existence, then in that case we can use sliding window. In that case it works very like it works perfectly. But in the problems, in the requirements where we have to count for any subarrays for a particular sum, in that case the sliding window fails, because the contradiction case comes where the counting problem says that for any particular index you are extending, multiple subarrays can be ending at this particular index, but sliding window says that whatever the fixed position is there for a j pointer, the I pointer will be standing at one index only, which will be forming at most one valid window, and because of which all the other subarrays which are there, which will be ending at this index, they gets missed. This is the exact reason that why the sliding window is not working in order to count the number of subarrays. So the problem is for counting requirement, not about the values. Okay, so we can see here that the count must come as 4, but it is coming as 3 because this I is not moving ahead. And even if we say that, okay, let this I move ahead so that this particular subarray can also be counted, but it will work incorrectly for the other cases. It is breaking the rule of the sliding window. So we can say that this particular problem which is coming, it is not a implementation issue, we can say. It is not an implementation issue. It is basically a design limitation, means how the sliding window is designed. It is not working in the case where we have to count the number of subarrays for a particular sum. This is the requirement problem. The requirement which we are having, that is the problem, not the values. Values are correct at their places because they are positives. So we say that the sliding window works for positives, but it is the problem of requirement where we have to count the subarrays, where the sliding window fails. Okay, so we have seen that why the sliding window is not used such problems. And that's all about this particular video, and we'll meet with the another videos for the further problems. Thank you.